Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving different practice questions that cut across different topics in chemistry. Now let's get into the first practice question, and it says, the highest isotope of hydrogen is. Now, this question is extremely very easy. Before we go ahead to choose the correct answer to this question, I saw a very important keyword in this question, and it is important for me to analyze that word so that it will be easy for us to answer this question. So listen carefully. That word I saw was isotope. So it is important for us to understand where this word is actually coming from. And from the look of things, the word isotope came from another term called isotopy. This must be noted. So I will start by explaining to you what isotopy is all about before we can come back to this word isotope and then read the question again to analyze the options and get the correct answer to the question. So what is isotopy? Now listen carefully. Isotopy is a phenomenon whereby atoms of the same element, you can see S was added to the atoms, meaning that it is not just one atom, more than one atom. So isotopy is a phenomenon whereby atoms of the same element. Now let me explain what I mean by this first statement I said. Isotopy is a phenomenon whereby atoms of the same element. So you can see I'm stressing on the word atom. So listen, I have to explain to you what an atom actually is. Now let's take an example of using oxygen as an element to explain what an atom actually is. So watch closely. Now let's use oxygen as a case study. Oxygen is an element. Now it must be noted here that oxygen as an element is symbolized as O. I believe you know this. So this must be noted. So let me explain to you. Whenever you see oxygen symbolized as O like this, that oxygen specifically is existing in its atomic state, meaning that this standing here should be pronounced as oxygen atom. So this you are seeing here should be pronounced as what? Oxygen atom. Now, oxygen atom is different from oxygen molecule. You can see I call the word molecule. A molecule is different from an atom. A molecule is made up of at least two atoms. So listen carefully. What did I just say? A molecule is made up of at least two atoms. So for we to get a molecule, we need at least two atoms of that element or different elements coming together. So listen carefully. This we already agreed that is oxygen atom. So let's say another oxygen atom is bonding to this. What do we now have? We have two oxygen atoms together. So now it will now be written as O2. And I just explained to you that a molecule is made up of at least two atoms. So you can see here that we have two atoms of oxygen. So this O2 you are seeing here should be pronounced as oxygen molecule. And this I just explained corresponds to all elements in chemistry. So this must be noted. So if for instance hydrogen is standing, like as H you are looking here, how will you pronounce that? That is hydrogen atom because it is just the symbol of the element standing. Are you there? So when the symbol of that element standing, it should be pronounced as that element's atom. But when we have more of that element standing like H2, that should be pronounced as hydrogen molecule. I believe you understand what I just said now. So let's say H bonding to another H. What do we have? H2. So this is hydrogen what molecule.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
So moving further, let's get back to what the word isotopy is. It's important for me to just explain all of these things because it will help us in solving other questions as we go on in this video lesson. So isotopy is a phenomenon whereby atoms of the same element. So I'm using oxygen atom as the case study here. So it's going to be what now? Two oxygen atoms standing alone. Like I said, atoms, you understand? It can be more than two. You understand? It can be 3, 4, 5, 6. But you must understand what isotopy explains. So it's a phenomenon whereby atoms of what? The same element. For you to be called an isotope, you must be made up of the same elements. Are you there? So isotopy is a phenomenon whereby atoms of the same element have same atomic number. What did I say? Have same atomic number. And where is this atomic number located in these atoms? It is located down. It is located what? Down. And you must understand here that the atomic number of oxygen is 8. Are you there? Both of them is 8. I believe you are following me. Atomic number is located down. So I said, let me take it again. Isotopy is a phenomenon whereby atoms of the same element have same atomic number, and we have agreed that the atomic number is located down, same atomic number, but different mass number. So what is different here in isotope is their mass number, and this mass number is located up. Are you there? I have video lessons that explains all of these concepts, specifically in solving questions relating to the subatomic particles that are found in an atom, and there are 3 of them, which are protons, electrons, and neutrons. Are you there? How to determine the numbers of protons, electrons, and neutrons in an atom. The video will be here, so you can, after watching this video, you do well to go watch that particular video lesson to understand perfectly how that is done. So let us progress. So isotopy is a phenomenon whereby atoms of the same element, oxygen, have same atomic number. You can see the atomic number is located down, but different mass number. This particular oxygen you are seeing here, the mass number is 16. This particular oxygen you are seeing here, the mass number is 18. So let's take it again. It's a phenomenon. Isotopy is a phenomenon whereby atoms of the same element, oxygen, have same atomic number, 88, but different mass number. So you can see here that both of these elements standing together, how do we describe them? They are isotopes. They are what? Isotopes. So moving further, let's get back to the question. I believe you understand the overview of isotopy now. So the question now says the highest isotope of hydrogen. So you can see now this question talks about hydrogen. What I just explained for you is for oxygen. So this is something you must know. Hydrogen has 3 important isotopes, which are protium, deuterium, and tritium. What are they? Protium, deuterium, and tritium. These are the isotopes of hydrogen. And all of these isotopes, you know, they have their symbols to note them. Are you there? So you can see I did not even stress on option D because option D is called positron. Positron is not an isotope. Positron is a type of radiation. Are you there? In the topic radioactivity, I've explained this on my channel. So it is important for you to go watch that video lessons that explain the concept of radioactivity, so you see where this radiation come into play. But I'm still going to tell you the symbol to note this radiation, because radiations as well have their respective symbols. For positron, positron is also regarded to be called a positive electron. Normally, electrons are negatively charged, but this is a special type of radiation which is called positron, which is also regarded to be called a positive electron. So this radiation you are looking at is E electron with a positive charge. Are you there? And it's actually symbolized as E plus 1 and 0. I believe you are following me. It's very simple. We have the brother of positron, and that is called negatron. Negatron symbol is almost like this. Negatron is negative electron. What did I say? Negatron is negative electron. It is electron with a negative charge, which you are just seeing here. So this will be explained more in the topic radioactivity, which I already have on my channel. So make sure you go watch that particular video lesson. So moving further, let's get back to all of these isotopes of hydrogen. Remember I told you that all of these isotopes, all right, be it of hydrogen or any other element, have their respective what symbol, and I'm going to write them here. For protium, I'm going to start with protium. It is symbolized as H, hydrogen is symbolized as H. So one of the isotopes should also be symbolized as H as well. All of them is simply symbolized as H. But there are some numbers you should take note that is written in these symbols. So basically, let's just say all of them is symbolized as H. Let's just write H on them. But I'm going to write out the specific numbers allocated to these isotopes. Remember, these guys are isotopes and you're seeing the numbers allocated to them. So know why the numbers are like that. It's simple. You understand? Most importantly, this one that is written down, that one that is called the atomic number. To get your atomic number is simply by reading out the elements as written in the periodic table. You understand? As a science student, you have to know the first 20 elements and know how they are arranged. Hydrogen is number 1. You understand? So the atomic numbers of these isotopes of hydrogen will be 1, 1, and 1. Are you there? Because I told you the number that is always written down is simply called atomic number. And how do you get atomic number? Reading out the first 20 elements: hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6. You understand now? So when you read out the first 20 elements, the number they fall under is the atomic number. And it is for hydrogen. That's why all the atomic numbers should be 1. Are you there? So these ones that are up now is the mass number, and it differs based on the isotope. And this is where you have to listen carefully. For protium, the mass number is 1. For deuterium, the mass number is 2. For tritium, you can see the word tri means 3. For tritium, the mass number is 3. Are you there? So with these, we've gotten the answer already. The isotope of hydrogen that is highest, all right, the highest isotope of hydrogen is what? Looking at all their symbols, let's use the mass number to get the answer, because now we cannot use the atomic number to get the answer. Remember, don't get this wrong. The atomic number is located down, the mass number is located up. So if we want to use the atomic number, we can't do it because all the atomic numbers, the 3 of them is simply 1. So we simply go back to use the mass number. And the mass number for protium is 1. Is this the highest? No, it's not. The mass number of deuterium is 2. Is this the highest isotope of hydrogen? No. The mass number of tritium is 3. That is the highest isotope of hydrogen. So the answer to this question becomes option C. You can see how it was analyzed. It is very easy.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
So if you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my videos with your friends. So let's get into the next practice question. The question says, the carbon atoms in 18. This is very important. Listen carefully. This question is extremely very easy. From the look of things, since I saw this compound 18, it tells me that this question is from the topic in chemistry called organic chemistry. And it is very easy. If you are finding it difficult to learn how to name organic compounds, worry no more, because there is a video here on my channel that explains extensively on that aspect. So the video will be here on the screen. So after you're done watching this video, make sure you go watch that video on how to name organic compounds. So let's get back into this question. The question says the carbon atoms in 18. I already know that, oh, this compound ended with ENE because 18 is an hydrocarbon. In organic chemistry, the word hydrocarbon, there are groups of compounds. From the word hydrocarbons, they are compounds that are made up of two elements only, which are, you can see the word hydrocarbon, they are made up of hydrogen and carbon. And we have three major groups, which are the alkane. So let's go. We have three major groups of the hydrocarbon because we have to know where this actually came from. So we have the alkane, we have the alkenes, and lastly we have the hydrocarbons called the alkynes. All of these, group of compounds, they are hydrocarbons. So you can see this one ended with ANE, and this must be noted. It must be noted here that the hydrocarbons called alkanes, generally they are single bonded with just one bond. For alkenes, they are double bonded compounds, all right? The bonds that hold the carbons together is simply a double bond. So we simply say that compounds with double bonds, they are called alkenes. Moving over to alkynes, they have triple bonds in them. The bonds that hold the carbon atoms in alkyne, they are triple bonded. So this must be noted also. Compounds that are single bonded, they have a special type of hybridization, which is called the sp3 type of hybridization. Hybridization is a topic on its own in chemistry, but this I'm saying is very important. Note it. Whenever you see questions on this aspect, please note this thing I just said. Compounds that are double bonded, their hybridization generally in alkenes now, because they're double bonded, is simply sp2 hybridized. I believe you are following me. And compounds that are triple bonded, they are generally sp hybridized. Are you there? So if you observe now, you can see from the spelling alkene, what ended it? ENE. From this compound, even if you don't know the compound's chemical formula, just look at the end name. It ended with ENE. So it tells you that this is a member of this family. All of them are families, all right? So this is a member of this family. So generally, since they are sp2 hybridized, then the carbon atoms in this compound definitely will be also sp2 hybridized. Are you there? So the answer to this question becomes option A. You understand now, because the carbon atoms in this compound, they are generally sp2 hybridized. So this must be noted. Let's get back into the next practice question, and it says, what is the partial pressure of oxygen gas? You don't have to be scared. This question is very easy. So listen carefully. It says, what is the partial pressure of oxygen gas collected over water? Wow. Whenever you see a practice question in chemistry and they specifically said that a gas, okay, was collected over water, I already know the concept to which this question is from. Before I finish reading this question, I have to tell you the topic to which this question is from. This question is from the gas laws, specifically Dalton's law of partial pressure. Are you there? And it's on a very important aspect on Dalton's law of partial pressure. It's on the aspect that talks about collection of a gas over water. Are you there? Because I saw in this question that they said, what is the partial pressure of oxygen gas? Leave that alone. Collected over water. So please, before I go read this question till the end, let me just tell you what you have to note here. Whenever a gas is collected over water, all right, there is a formula you must actually note. All right, it's very simple. There's a formula you must note on this aspect whenever you see that a gas is collected over water, and that formula is simply this I'm writing now on the board. Is simply PT, I'm going to tell you what PT means. Let's progress. Is equal to P gas. I'm going to tell you what P gas means. All right. Plus P water vapor. I believe you know that water vapor itself is simply water. H2O. So whenever you hear that a gas was collected over water, this is the formula you must note, and it is PT is equal to P gas plus P water vapor. What is PT? Very simple. PT is like you say TP, all right? It means total pressure. It's like you're calling the T first when you are pronouncing it. Is equal to P gas. Now, P gas here means partial pressure. The P in the gas means partial pressure. Whenever you see like P standing in front of a gas, it should be called partial pressure. I know it's pressure, but make sure you put the word partial. You see what I'm talking about as we go ahead to solve this question. So listen carefully. PT, total pressure. P gas, partial pressure of that gas. So if it's oxygen, it's going to be partial pressure of oxygen. If it's hydrogen, it's going to be partial pressure of hydrogen gas, partial pressure of oxygen gas, partial pressure of nitrogen gas, as the case may be. So listen carefully. All right, whereby H2O is the partial pressure of water vapor. So before we go ahead to finish solving this question, just solve a question based on question 2, and you tell me the hybridization that is seen in this compound called ethyne. And I told you to do that is simple. Just look at the engine name of that compound and know the family to which it belongs to. So if it's an alkane, alkene, or an alkyne, then you know the type of hybridization you are assigning to that compound, specifically to the carbon atoms present in that compound. You can say I'm not drawing any structure here. I've done it on the video how to name organic compounds. So make sure you go watch that video after you're done watching this video. So let us progress. So the formula to solve this question is simply PT is equal to P gas plus P water vapor. And then I'm going to read the question so that we analyze all the parameters and know what exactly we are looking for. It's very simple. So listen carefully. So let's get back to the question. The question says, what is the partial pressure of oxygen gas? Wow. What do you think they're asking us to actually look for in this question? You can pause this video and then comment down the answer. Simple. They said, what is the partial pressure of oxygen gas? That means they are asking us to look for partial pressure of gas. They are asking us to look for P gas. That's what the question says. I've explained this thing to you already. It's simple. What is the partial? I told you the P standing in front of that gas is partial pressure. So definitely this is what they're asking us to get. P gas. Are you there? So when we have to make subject, we have to make P gas subject of formula. So just listen carefully. But let's read the question till the end. So what is the partial pressure of oxygen gas collected over water? Since we already see collected over water, that's why we arrived at this formula. So moving further, at 760 mmHg, you can see here, 760 mmHg. That 760 mmHg, please, if you don't know it, please know it from today. It is standard pressure. It is what? Standard pressure in mmHg. We have standard pressure in different units like in ATM. Standard pressure in ATM is 1 ATM. But standard pressure in mmHg is 760 mmHg. And that value is always your PT. It's always the total pressure of the gas mixture. Do you understand? Because if I have to give you another practice question, that 760 will still be there. But I'm going to tell you what it will change. Do you understand? So that is our PT. PT becomes 760 mmHg. Do you understand? That's the standard. Sometimes they will not give you like at 760 mmHg. They will just say a word. They will say at standard pressure. So what will you write? What will you say? 760 mmHg. I know you want to ask this question because there's also 1 ATM to be standard pressure. But the reason you always go for 760 because the other pressure they will give to you, the partial pressure of that water vapor will be expressed in mmHg as well. So make sure you always use that as your standard in this aspect of collection of a gas over water. It's simple. Just listen carefully. So moving further, we've analyzed from the beginning till this part. Then I said, if the saturation vapor pressure of water Wow, that is water vapor. If the saturation vapor of water is 23 mmHg, so this tells us that the the pH2O is 23 mmHg. So if the saturation vapor pressure of water is 23 mmHg at 25 degrees Celsius, you know that 25 degrees Celsius is telling us that telling us that this reaction is actually occurring at room temperature. But you must note here that in this aspect, in this topic, specifically in this collection of a gas over water, we don't use temperature. Did you see anything like temperature in this formula? No, you did not. So this 25 you just saw, we are not using it. Do you understand? So you can see we've analyzed all what we need, and we've also analyzed what we are looking for in this question. And what we are looking for is the partial pressure of gas, is the partial pressure of oxygen gas. Do you understand? Gas generally, but to be specific in this question, is oxygen gas. They can also ask you to look for partial pressure of nitrogen gas. So it's simple, it's not difficult. So the task for us right now is to make P gas subject of formula, and to do that is extremely very easy. To make P gas subject of formula, what will happen? I'm going to move the P water vapor crossing the equality sign to this side. So when I do this, P water vapor will cross and come here. You understand? When it comes here, it's going to be negative P water vapor. Do you understand what's happening? It's going to be what? Negative P water vapor. It was positive before, but when it crosses, it's going to be minus. Do you get? So now let's write out P gas as a subject of formula in this particular equation. So doing that, we are going to have something like P gas, all right, is equal to PT remains PT minus, you understand? Now this guy has crossed, so minus P water vapor. Do you understand? So minus P water vapor. Do you get what's happening? What will happen now is to impute our parameters. To do that is simple. Let's impute the parameters. Let me do it here. So it's going to be, P gas, that's what they're asking us to get, is equal to PT, total pressure of the gas mixture, and it is 760 mmHg. So here is 760 minus P water vapor, it is 23 mmHg. So 23 is equal to, so let's press our calculator, 760 minus 23, that is 737. Wow. So the answer to this question becomes 737 mmHg, and you can see it's very simple. So the answer to this question becomes option A. You can see how it was solved and analyzed. It is very cheap. It's not difficult. So get ready for your own practice question, whereby they're still asking you to get the partial pressure, but let's say now is nitrogen gas. It can be of any gas, so you don't have to be scared. All of them are the same approach, all right, of nitrogen gas collected over water at this is a constant, you understand, because that's a standard pressure in mmHg, whereby the saturation vapor of water should change. So here I'm going to make it 30. You understand? So when I make it 30 mmHg, then you solve the question. It is very simple. So let's get into the next practice question. The question says, a sample of an ID gas. Wow. Whenever I see the word ID gas, I have to take note of it because it will help us solve this question. It is simple. A sample of an ID gas contains 0.176 moles. All right. It's very simple. Just listen. And occupies 8.64 liters. The L there means liters. So this must be noted. Whenever I see this word in any question under the gas law called ID gas, there is a formula that must come to my mind, and that formula is what I'm about writing on the board. The formula is simply PV is equal to nRT. This is the formula you must note. Whenever you see the word in any question in chemistry, ID gas, make sure that this formula comes to your mind. Let's continue reading the question to know exactly what they are asking us to find in this formula. Are you there? It's very simple. All right, it says a sample of an ID gas contains 0.176 moles. All right, whenever we hear moles, what should come to our mind is a symbol which is N, small letter N. So me seeing this now, I already know that it is small letter n, and this simply means number of moles, and they gave us in the question to be 0.176 moles. And in the formula, it was present n. Are you there? So you can see that all the parameters given to us corresponds to the formula I actually wrote initially. All right, and occupies 8.64 L. 8.64 liters. The L there means liters. So 8.64 liters. And anytime we hear liters, what should come to our mind is simply volume. It's simply what? Volume. And V is in the question. So volume given to us in the question was 8.64 liters. Are you there? So moving further, at a pressure, they actually stated at a pressure of 0.432 atm. So you can see the pressure in the question given to us, which is P, which is part of the formula, is what? 0.432 what? atm. All right. So this is what the question says. The question now says, what is the temperature of the gas? That means from this question, they are asking us to look for temperature, and temperature is here as well in the formula. So they are asking us to look for T. What is the temperature of the gas? To solve this question is extremely very easy. If you observe, I've written all the parameters given to us in this question, and there's one other thing remaining. And what is that? It is simply arrow. You can see we're not given arrow in the question. So this must be noted. Arrow is a constant, and the constant is pronounced as, or is called, molar gas constant. If we don't call it that, we simply call it another name called LD gas constant. Are you there? Is a constant. And for the level of the JAMB exam, you must note that we have two different constants for arrow for the JAMB exam. And what are they? That's what I want to stress on now. So we have the first arrow constant to be 0.0821. Yes. And we have the other arrow constant to be 8.314. Whichever the one we use in solving this question, we are to arrive at the same answer if we follow specifically the criteria to which this constant works. And I'm about telling you how to use this constant. So listen carefully. For us to use this first constant, which is arrow, is equal to 0.0821, the criteria is based on two parameters, which are pressure and volume. Which are what? Pressure and volume. For us to use this first one, 0.0821, the pressure in the question must be expressed in atm. If the pressure is not expressed in atm in that question, try your best to convert that pressure, all right, to atm. If the pressure is in another unit, make sure you convert it to atm. But in this question, you can see they make things easy for us. The pressure was converted already to atm. The pressure was given to us in atm. So this is a confirmation that we should work towards using this constant. But it's best for you to still learn using this constant, and I'm going to teach you how it works. It's simple. Just listen carefully. For the volume in the question must be expressed in either liters or dm cube. If the volume is not expressed in any of these, you know that you cannot use this constant. Are you there? But if you want to make things easy for you, try to convert the volume to whichever the unit was, so this unit either liters or dm cube. And to do that, I already have a video lesson that explains the gas laws in general. So make sure you go watch those lessons. All right, you'll see the video here on the screen. So at the end of watching the video, make sure you go watch that video. All right, so you can see the criteria to which we use the first constant. So for the other constant, what is the criteria? For this other constant, what's the criteria to which we use this constant? The pressure in the question must be expressed in a pressure unit called Newton per meter squared. Are you there? Newton per meter squared. Do you understand? That's the unit to which your pressure should be. Whereby the volume in the question must be expressed in this unit, and it is meter cube. If the pressure or volume is not expressed in any of these, don't use this. Do you understand? But most times in the JAMB exam, JAMB always stress on using this first constant. So that's why you should just work on this And if you observe, the question given to us is based on the concept of using this constant because the pressure was given in atm, the volume was given in liters. You can see, so this 8.64 liters is same as 8.64 dm cube. Do you understand? It's very simple. So this is a confirmation that we have to use our R to be 0.0821. Do you get what I'm saying? So now what do we do next is to make whatever they ask us to get subject formula. You can see from this question, they're asking us to get temperature, and to do that is very simple. So what do we do first? We have to make temperature subject of formula, and to do that, you divide both sides of the equation by the coefficient of temperature, by what is close to temperature. All right, this is temperature. So what is close to temperature is the coefficient of temperature, and it is simply n and arrow. Are you there? N and what? Arrow. Then n and arrow is to cancel each other here, leaving just temperature. So you can see here that temperature will now be equal to PV over n arrow over what? N arrow. So let's impute our parameters into what we've gotten. So the pressure, first of all, is this. So we're imputing. So it's going to be what now? T will now be equal to pressure, which is 0.432 atm times what the volume. The volume in the question was given to be 8.64 liters. So here it should be 8.64 liters divided by what's the number of moles given to us in the question? It was 0.176. All right, 0.176 moles. That's the unit for number of moles. All right, times the molar gas constant, which is the arrow. It was given to us to be not given to us. I told you already. All right, so you should note it. 0.0821. So let's impute all of this into our formula. So let's see what we get. So 0.432 times 8.64 divided by 0.176, all right, times 0.0821. We are having 258.3, all right, 258.3 Kelvin, all right. So the temperature should be 258.3 Kelvin, K. You can just call it K. So let's see the one that corresponds to what we've gotten. All right, the closest answer here is option A, 258.5 Kelvin. All right, maybe there was an approximation. Okay, done. That's why they call this to be the answer, but that's the answer to the question. Option A is the answer, not option B, which is 200, not option C, which is 273, and not option D, which is none. All right, the answer is option A. Now, listen carefully. There's something I have to tell you. If you observe, you can see that we were asked to get temperature. And if you now observe, you know, temperature is expressed in different units. Temperature can be expressed in Kelvin, as you are seeing here. Temperature can be expressed in degrees Celsius, all right. Temperature can be expressed in Fahrenheit scale. Temperature can be expressed in Rankine scale. Do you understand? So please take note, whenever you are to solve any question on gas law, be it Aldi gas law, Boyle's law, Charles law, the general gas equation, Graham's law of diffusion, this your temperature must always be in Kelvin, except the question states that you should make sure that the temperature you are getting should be converted to degrees Celsius. That's when you now convert it to degrees Celsius. So for you to even do that, you have to make sure you get your answer in Kelvin, then convert it back to degrees Celsius. And to convert any temperature value to degrees Celsius is simple. You just have to note this formula, which is degrees Celsius plus what? 273 is equal to Kelvin. So if they ask you to get degrees Celsius, you make it subject. You can see already that Kelvin is equal to 273 plus degree Celsius. Do you understand? So if you have to make this subject, this guy will move. So when this guy crosses, it's going to be Kelvin minus 273 because it's plus, but when it moves, it's going to be minus. So if you have to convert this guy back, so you won't do it for me in the comment section. Provide the answer in the comment section. The answer we've gotten, convert it to degrees Celsius, and I've given you what you need. To do that, make this subject, you have to make this subject move this 273 plus 273, crossing the equality sign, so it will be minus, it will be Kelvin minus 273. So you get your answer in degrees Celsius, and get ready for your own practice question based on this concept, and it's very simple. So here is your own practice question. I'm going to change here to the number of here will be 0.5. All right, here will be, let's say, here will be 6 liters. Pressure will be, let's say, 0.38 atm. We are still looking for temperature. All right, so you are getting the answer in Kelvin, and at the end, convert it to degrees Celsius for me. All right, make sure you put the answer in the comment section. But for this I give to you, also do it and make sure you put the answer in the comment section as well. It's very simple. So listen carefully. So let's get into the next practice question, and it says,
to have more understanding about chemistry calculations and solving all of this type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
which of these is the symbol of alpha ray? Alpha ray is a type of radiation in radioactivity. Remember, radioactivity is the spontaneous emission of radiations, and alpha ray is one of them from the nucleus of an atom. So these radiations are coming from the nucleus of an atom. We have two major groups of radiations, which are the major radiations and minor radiations. For the major radiation, we have three of them, which are alpha, beta, and gamma radiation, or you call it alpha, beta, and gamma ray. All of these radiations have their symbols. I already have a full video lesson that explains on this, but you must just note here that alpha ray or alpha radiation is symbolized as helium atom He42. So the answer to this question is option C. This guy means something, this one means something, the other one means something. So go watch my full video lesson on how to solve questions under that aspect. Okay. So let me just tell you, this one that is B0 minus 1 is beta. This one that is this symbol 00 is gamma. This one is neutral, all right? But it's important for you to go watch that video and know how to balance what we call nuclear reactions. It's on the aspect of radioactivity. There are so many concepts on radioactivity which I already have video lessons for. So make sure you go watch it on my channel, all right? I already have the list of videos, and these videos are arranged in different playlists. So make sure you go watch those video lessons. So if you find my video lessons helpful, make sure you click on the subscribe button to my channel and also share my videos with your friends. So let's get into more practice questions. So let's get into the next practice question, which is question number 6. And it says, the ability of an acid to remove rust from metals, what's that process called? It's simply called pickling. Take note. The ability of an acid to remove rust from metal is called pickling. And there is a common acid that is used, and it's called hydrochloric acid, HCl. Are you there? So all these must be noted. Let's get into the next practice question. And it says, industrial production of graphite is called. So when graphite is produced industrially, what is that called? It's simply called the Alkalis process. This must be noted. It's simply called the Alkalis process. Moving over to the next question, which says, industrial production of sulfur is called. That's the process used to produce sulfur. The process is simply called Frisch process. What did I say? Frisch process. It was discovered by a man called Hermann Frisch. That's why they named it after his name, Frisch. So it's called Frisch process. Now let's get into the next question, and it says, what is the chemical formula of green vitriol? Green vitriol is a compound that is very important, and it has its chemical formula to be, okay, since it's green, then it's iron sulfate, FeSO4.7H2O. This is what we call green vitriol. But moving over to white vitriol, what's the chemical formula of white vitriol? It's still almost like this, but this is made up of zinc instead of iron. Zinc sulfate. Whenever you see SO4, it's called sulfate, all right? So zinc sulfate dot 7H2O. So this tells us that this compound, they have water crystallization in them. We also have what we call blue vitriol. Are you there? So let's get into the next question, and it says, the positive electrode in an electrolytic cell is called. We have two types of cells. We have electrolytic, and also we have electrochemical cell. All of these are from the topic in chemistry called electrolysis, all right? Now, this must be noted. It must be noted here that in either of these cells, be it electrolytic or electrochemical cell, both of them are made up of what we call terminals. These terminals are where electrons actually flows. They're also called electrodes. Now, electrodes in general, they are of two types, all right? We have the anode, and also we have the cathode. So for instance, I'm talking about, not for instance now, because we are talking about electrolytic cell. So then you have to know that in an electrolytic cell, the positive electrode is the anode, whereby the negative electrode is the cathode. But if I talk about electrochemical, is the opposite. All right, electrochemical is the opposite. So let's answer this question first. The positive electrode in an electrolytic cell is simply called the anode. Here becomes anode. Are you there? But if we talk about the electrochemical cell, it's going to be the opposite. Electrochemical. Here is it. Electrochemical cell. Then the anode, they are still terminal anode, cathode made up of, they are found in the electrochemical cell. Anode is negative, cathode is now positive for electrochemical cell, but electrolytic cell is the opposite. Do you understand? So let's get into the next question, and it says O3 is oxygen atom. O3, is it pronounced as oxygen atom? No, it's not. All right. So the answer to this question is false, because O3 is actually oxygen molecule. All right. I explained to you that a molecule is made up of at least, all right, 2 atoms. So when we have more than 2 atoms, it's still a molecule, but O3 specifically is called ozone. All right. So this must be noted. So let's get into the next practice question, and it says, how many elements are in sulfuric acid? You have to know here that sulfuric acid is H2SO4. Are you there? So how many elements can you see? I can see hydrogen, I can see sulfur, and also I can see oxygen. So there are 3 elements in what sulfuric acid. This must be noted. So let's get into the next question, and it says, what are the allotropes of phosphorus? They are the white phosphorus, black phosphorus, and red phosphorus. This must be noted. For the allotropes of phosphorus, there are 3: red, there is the black, and also there is the white. Are you there? Red, black, and white phosphorus. So let's get into the next question, and it says, the other name for hydrogen trioxonitrate 5 is simply, hydrogen trioxonitrate, its chemical formula is simply HNO3. There's a reason why it's hydrogen trioxonitrate 5. Let's get it straight. Hydrogen. Now, the way it works is, we have naming inorganic compounds, and also we have naming organic compounds. I already have videos that explains how to name organic compounds, but this is inorganic, all right? So there are principles to which we name inorganic compounds. Like you can see that this compound is made up of how many elements? 3 elements. To name inorganic compound, if it's made up of 3 elements, you call the first, you call the last, and you call the middle. So let's get it straight. It's hydrogen, trioxo. I said first, last, and middle. Hydrogen trioxo. Why is it trioxo? Because we have 3 oxygen. If it was 4 oxygen, it's going to be tetraoxo. Do you understand? So trioxonitrate, nitrate means nitrate. All right, that's nitrogen. Nitrate what? You can see here it's nitrate 5. There is a reason. Do you understand? There is a reason to which it's actually nitrate 5. In more video lessons to be out on my channel, I'm going to stress on this aspect. So basically, you have to just know that this compound is also called aqua fortis. Are you there? It's also called what? Aqua fortis. So that's the other name for hydrogen trioxonitrate 5 or nitric acid. Even if you don't call it even this name, we can even call it nitric acid. So listen carefully. So let's get into the next question, and it says, what is aqua regia? All right. You can see that aqua regia resembles aqua fortis. Actually, aqua regia is not a compound, but rather it's a mixture. It is made up of 2 different compounds together. So when we have 2 different compounds coming together, that thing cannot be a compound, but rather it's going to be a mixture. And what's aqua regia? Aqua regia is made up of 3 parts of HCl, seen initially, which is used to remove rust from metal, and 1 part of HNO3 called aqua fortis. That's what aqua regia means. Are you there? Aqua regia is a mixture, not a compound or an element. All right, because it's made up of different compounds, like 2 different compounds together. The next question says, NO2 is a bluish brown gas. That's wrong. NO2 is a reddish brown gas, not bluish. So this statement is false. Okay, it's a reddish. It's supposed to be reddish brown gas. All right. So this gas is supposed to be reddish brown gas. So this must be noted. NO2. So the next question says, what dries all gases? What dries all gases is called silica gel. All right. The next question says, what is dehydration? Dehydration. D means removal. Hydration is water. So removal of water. Removal of water. That's what dehydration means. Next question says, what is the basicity of HCl? First of all, you can see that basicity is explained, like that's majorly all the questions here. Basicity is seen in acids. Are you there? Basicity is seen in acids, whereby the other term called acidity is seen in base. So that's why we have what we call basicity of an acid and acidity of a base. What is basicity of an acid? It is the number of replaceable hydrogen ion found in one molecule of an acid. It's simple, just listen. So the first acid here is HCl. So then we say HCl. I want to break HCl. I want to dissociate it. So when I break it, we are having, since it's an acid, definitely it's going to have H plus. Do you understand? I will come to acidity, but we are on basicity first. Since HCl is an acid, it's going to have H plus. Acids that are defined by Arrhenius, they have H plus. We have different types of acids. All right, there are some acids that don't have H plus. Those acids are called Lewis acid, but I'm not talking about that right now. When we get there, we'll treat on that aspect. So HCl has H plus in it, so the remaining other part is Cl minus. Are you there? And if you observe, the reaction is balanced, all right, because we have just one hydrogen here, one hydrogen here for sure. So it's balanced. The H plus is 1 at the end of everything. So the H plus in this reaction is what? 1. So making this acid to be what now? This acid to be monobasic. Are you there? So the basis of HCl is 1, or we can as well say it is a monobasic acid. Why is it a monobasic acid? Because the basicity was 1. All right. What's the basicity of H2SO4? This is H2SO4, and I already agree what basicity is the number of replaceable hydrogen ion found in one molecule of an acid. One molecule means that it's just that acid standing alone. If it was 2 molecules, 2 will be at the front. Do you understand? But it is one molecule. So you can see here that H2SO4 is an acid. Then when we dissociate this acid, we are having, normally if you are an acid, you have H plus. So you can see that this is, the other part is SO4. SO4 is a radical, all right. SO4 is a radical. So we're having plus SO4 2 minus. The reason why it's 2 minus is because radicals are groups of atoms that bears a single charge. You understand? So there will be a charge that will hold all of these atoms together. You can see we have 1 sulfur atoms and 4 oxygen atoms together. So if you observe, the reaction is not balanced because we have 2 hydrogen here. So here should be 2 for sure. Do you understand what's happening? So if here is 2, so it tells us that the H plus in H2SO4 is 2. Then this H2SO4 is it mono or di? It is a dibasic acid because the H2SO4 was 2. Do you understand? So the basicity of H2SO4 is dibasic. All right, so here becomes 2, or you can say it is dibasic in nature. Do you understand? So when we go over to H3PO4, you can see the approach to which we solve all of these questions. For H3PO4, when we dissociate it, we're having H plus this other part, but it is PO4 3 minus. If you observe that, you can even get the reason why I'm writing 2 minus 3 minus. It's simple. It's basically based on the numbers we're having in the hydrogen. You can see that H2 was here, that's why it's 2 minus. You can see that H3 was here, that's why it's 3 minus. And the PO4 remains. It's simple and it's not balanced. Then we have to balance it because hydrogen here is 3. So here it becomes 3 as well. Do you understand? So this tells us that H plus is equal to 3. And when you are 3, you are tribasic. Alright, so the basicity of this compound is tribasic. So here becomes what now? Tribasic 3 or tribasic in nature. It's simple, it's not difficult. So let's get into the next practice question, and it says, what is the basicity of this compound? This compound you're looking at here is an acid and is simply called ethanoic acid. Ethanoic acid is a weak acid. It is an organic acid. So this is how it works. It's simple, just listen. If I'm to break ethanoic acid, if I'm to dissociate it, this is what we'll get. It's simple, just watch. All right. So we have to get something like CH3COO minus plus H plus. This is how it works. CH3COO minus plus H plus. If you observe, it is this hydrogen you saw at the end that was actually dissociated, that was splitted out from this compound. So making this H plus to be the hydrogen ion. So I know you can see 4 hydrogen here. It is not tetra basic. In CH3COH, because these are some questions you see in your JAMB exam, they ask you what's the basicity of this compound CH3COH. It is 1. The basicity is 1. Hence, this compound is what? It is monobasic. Are you there? It is monobasic. It is not di, tri, or tetra. All of these things are very easy. Just listen carefully. So the next question here is it. It says, what is the basicity of this compound? Here is the compound. It is COOH bond COOH. Actually, the reason why this works like this is because these guys, they are organic acids. They are what? Organic acids. They are different from the one just explained here. All of these are called inorganic acids. But the most important thing here is just understand that if you are, because these are some common JAMB questions, what is the basicity of HCl? You simply say 1, monobasic. What's the basicity of H2SO4? You simply say 2, dibasic. What's the basicity of H3PO4? You simply say 3, or tribasic. And for ethanoic acid, you simply say it is monobasic, because at the end of dissociating this compound, we add 1H plus at the end. That's how it works. It's simple. Just listen carefully. For this, actually, this is the 2 hydrogen that is being dissociated. So if we were to dissociate this, we are having something like COO minus bond, COO minus plus what? 2H plus, because you can see that we've removed 2 hydrogen. All of these things you just have to notice is on the topic acid, base, and salt. On subsequent videos, I'm going to create more videos that explains deeply on all of this concept. So this guy is what? It is dibasic because it has 2 hydrogen ion that was dissociated. So it is 2. Basicity of this guy is 2. I believe you're understanding the point. It's very simple. It's not difficult. Moving further, let's get into the next practice question. And if you observe now, is on acidity. All right. See, we have what we call basicity of acids, and we have what we call acidity of base. I'm going to explain, because all of these compounds given to us to get the acidity, they are all bases. Are you there? So now this is how it works. What is acidity of a base? That will be the question you ask yourself. What is acidity of a base? Now, acidity of a base is simply the number of replaceable hydroxide ion. So we'll watch out for this thing, OH minus, in this acidity of a base. Just listen, they are all simple. The first base I saw is NaOH. They asked, what is the acidity of this base, which is NaOH? What was it? It's simple. This is NaOH. Then if we are to dissociate it, we have something like Na plus OH minus. At the end of doing this, we had just sodium. Sodium is balanced. OH, that is balanced as well. So that at the end of dissociating this compound, how many of those OH did you see? Just 1 OH. Then it tells you that the acidity of this base is going to be 1. So if we were to use this concept of mono, di, or tri, we are going to say that it is monoacidic. Sodium hydroxide is what? Monoacidic. Are you there? It's very simple. Sodium hydroxide is a base, so it is monoacidic. Therefore, the next one, which is C open bracket OH close bracket 2, they are asking what is the acidity of this. So it's very simple as well. You can see that if we dissociate this compound, we are having something like Ca2 plus calcium. This is calcium, and calcium is 2 plus. Calcium is a group 2 element. All elements on group 2, they have plus 2 charge. Are you there? It's simple. To even know that calcium is plus 2 because of these 2 that was outside. If you observe the way I explained for acid, it's still like the way we explain for base. All these things are simple. It's just constant practice. Practice makes perfect. Are you there? When you practice and practice, all of these things becomes very easy for you. And I believe you are getting all of these. They are all simple. So then we are having OH minus because it's a base. All bases should have OH minus in them. Arrhenius bases, to be specific. We have what we call Lewis bases as well. All right. So moving further, what do we do next? If you observe, how many of these OH did we have here? 2 of it. 2 OH. You understand? So 2 should be at the front. Do you understand what's happening? They are all very simple. So then what do we have for this? Acidity is going to be 2. Hence, this compound is what? It is diacidic. It is what? Diacidic. All these things are simple. You do for this one for me. You do it for me. It's simple. So just tell me the acidity of this base, which is this aluminum hydroxide. You tell me the acidity of this base. All right, we can actually use the arrow like this. Any of them you want to do, you are correct. Okay, so Please break it down. It's between aluminium and you can see how many OH we are having here. So this will tell you the acidity. It's simple, all right? So what is an alkali? That's the next question. Question number 28. It says, what is an alkali? An alkali is simply a basic soluble hydroxide. An alkali is a basic soluble hydroxide. So this tells us that all alkalis are bases. You can see the word basic. It came from the word basis. So all alkalis are bases. All alkalis are what? Bases. Are you there? But if we take it reverse what I just said, all bases are not alkalis, because alkalis, they are bases, they are soluble, and they are hydroxide. Hydroxide means that they have OH in them. Are you there? Because all bases should have this, but it is not all bases are actually soluble. We have some bases that are insoluble in water. You understand? This definition is definition for alkalis. Alkalis are different from bases. Do you understand? So let's get this straight. Alkalis are basic soluble hydroxide, but bases are hydroxides. Do you understand? Bases are what? Hydroxide. All these are bases. You understand? They have OH in them. Hydroxides. Do you get? So, but you must understand here that not all bases are soluble. Do you understand? So we cannot say bases and alkalis are completely the same. Do you get? Some bases are insoluble in water, but alkalis are generally soluble. That's why you saw the word basic soluble hydroxide. Are you there? They are all simple. Just listen carefully. So let's get into the next question, and it says, what is a strong acid? All right. This is simple. A strong acid is an acid that ionizes completely in water, that dissociates completely in water. But for the next question here, it says, what is a weak acid? Weak acid is the opposite of what I just said. For weak acids, they don't ionize completely in water or in a solution. They ionizes partially. Do you understand? Strong acids ionizes completely. Weak acids ionizes partially in a solution. So I believe you are following. They are all very easy. Now let's get into the next practice question. Let's move over to the next practice question, and it says, when delta H is less than 0 in a reaction, the reaction is... Now, first of all, we must know what delta H is. Delta H we are looking at here is simply called enthalpy change. Are you there? If it was just H, it would be called enthalpy. But there is delta, that means change, so it's called enthalpy change. Are you there? Delta H has two important signs you should note. Delta H you are looking at here can be either positive or can be either negative. So, common knowledge, all right? When this delta H is, what value do you think is going towards? You know, when you check the number line system, all right, let's say this is a number line system, here is zeros. Those numbers that are before 0, they are all negative numbers. Those numbers that are after 0, they are positive numbers. I believe you know this now. So you can see that when delta H is less than 0, what does that tells you? It tells you that delta H is negative. And when delta H is negative, it tells us that that reaction is exothermic in nature. Are you there? There are other criteria for delta H to be negative, all right? But you must know here that if delta H is negative, it means that that reaction is exothermic in nature. Are you there? We have endothermic reactions. Exothermic reactions, they give heat to their surrounding. Endothermic reaction, they absorb heat. Do you understand? So if it is positive, then delta H is going to be what? Endothermic. Do you understand? They are all very simple. So let's get into the next question, and it says the nucleus of an atom is made up of two important subatomic particles. All right, this is the nucleus of an atom. This is an atom. You know, an atom has three important subatomic particles, which I call PEN. All right, protons, electrons, and neutrons. PEN, protons, electrons, and neutrons. All right. So now this is the nucleus. It is centrally located. You must know here that it is made up of just protons and neutrons. So the particles found here is protons and neutrons. Are you there? So this must be noted. So let's get into the next question, and it says protons are dash charged, meaning that they are asking what's the charge of protons. You must note here that protons are positively charged generally. Electrons are negatively charged, neutrons are neutral. So the next question says X-ray was discovered by who? Very simple. X-ray was discovered by a man called Wilhelm Röntgen. All right, Röntgen. This is why the X-ray is also called the Röntgen's ray. All right, because it was discovered by this man called Wilhelm Röntgen, not Williams. All right. So let's get into the next question, and it says electrons are dash charged. They are negatively charged. We've talked about that already. So let's get into the next question, and it says, all right, this particular question, I actually specifically wrote them here, is on the topic quantum number. All right, part of it though. There are other things you should learn here, but it's important for me to just say this. So this must be noted. If you observe, they said the maximum number of electrons allowed for the M shell. Very simple. You know, in quantum numbers, you'll be seeing terms like shells, you'll be seeing terms like orbitals. So in chemistry, generally, we have different shells, which are the K, L, M, N, O shells. All of these are shells. K shell, L shell, M shell, N shell, O shell. We have orbitals as well, which are the S orbitals, the P orbital, the D, S, P, D, F, even the G orbital as well. All right. All of these shells and all of these orbitals I just mentioned, these ones are shells, all right, whereby this one down, they are orbitals. All of these mentioned, all right, they have their respective numbers allocated to them. For shells, their numbers is given by this value, which is n. N for the K shell is 1. For shell, we count them from 1, all right. So the n value for K shell is 1. For this is 2, 4, 3, 4, and 5. All right. So if you observe, for these shells, their number starts from 1, 2, 3, 4, 5, and they are given by which symbol? N. That N is called something. N is called principal quantum number. Because in quantum number in chemistry, we have 4 quantum numbers. We have the principal, we have another quantum number called the azimuthal, we have the magnetic quantum number, and the spin quantum number. So N is principal quantum number, and it starts from 1. Whereby for orbitals, it's the quantum number that gives numbers to these orbitals is the azimuthal quantum number, and it is symbolized as L. It starts from number 0 down to 1, 2, 3, and 4. So if you observe what's happening, all these things are simple. Just listen carefully. For this one, L is azimuthal quantum number, N is principal quantum number. Get that in your mind. And I believe you can see the numbers allocated to all of these shells and orbitals. Don't forget this. This is very important. So with this, let's get back to the question. The question says, what? Okay, it says the maximum number of electrons for the M shell is what? All right. So this is very simple. Just listen. They are asking us to get the maximum number of electrons that will be inside the M shell. And to do that is simple. Just notice. To get the maximum number of electrons in a shell, it is done by a formula, and that formula is simply 2n squared. To get the maximum number of electrons in a shell, be it the K shell, N shell, NO shells, in shells generally, what the formula? 2n squared. So the question is simple, because we'll just come here. Which shell are they talking about? They are talking about the M shell. And what is the N value for the M shell? What's the N value for the M shell? What's it? 3. We've said that already. So it is 3. And we are getting the maximum number of electrons. So maximum number of electron will be what? What should be this? What's the formula? It is 2n squared. So all right. So what becomes a 2 into n is 3. Do you understand? Close brackets. You know. So what we have is going to be 2 into 9, right? Yes, because 3 raised to the power of 2, that's 9. 3 raised to the power of 2 means 3 times 3, 9. Do you understand? 3 raised to the power of 2 is 9. If 3 raised to the power of 3 is going to be 3 times 3 times 3, but the formula is 2n squared. So 2 times this 8, the 2 outside times this 9, we are going to get 18. So in summary, we have 18 electrons in the what? M shell. 18 electrons were in the M shell. So the answer becomes 18 electrons. Do you understand how this question was solved? It's very simple. There are other concepts to learn on this aspect, all right? But it's important for me to quickly say this. That's why I'm saying it right now. So let's get in. All right, 37 you do it. It's similar to 36. I had to make sure that I double the question so you used to practice. All right. So if you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my lessons with your friends. All right. So you are calculating for the maximum number of electrons in the L shell. So you are working towards L. So use the N value to be 2 for L. Do you understand? It's simple. So let's get straight into question number 38, and it says,
to have more understanding about chemistry calculations and solving all of this type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
how many degenerate orbitals are allowed for the p orbital? Degenerate means ability of an orbital to actually break. You understand? How many orbitals can we form for each of these orbitals? It's simple like ABCD. Listen carefully. To get the number of degenerate orbital, there is a formula you should note. To get the number of degenerate orbital, there is a formula you should note, and that degenerate orbital is symbolized as d, small d, we are looking at here. We are talking about number of degenerate orbital. There is a formula you should note, 2l plus 1. Do you understand? It's not difficult, it's very simple. So let's go over to the question number 38, and it says, how many degenerate orbitals are allowed for p orbital? So you can see p orbital. What's the number allocated to p orbital? What's the value for L for p orbital? What's it? Is it not 1? What's the value for L for p orbital? Is it not 1? Yes, it is. So since we are on p orbital, what we do is very simple. Just listen. The value for L for the p orbital, what's it? It is 1. We talked about that already. So we are going to write under p orbital 1, L is equal to 1. So because this is what we just need to solve this question, because L was in the formula. So what becomes D? D will now become 2L plus 1. So it's equal to 2 into 1 plus 1. Do you understand? Because the L is 1. This bracket here means time. So 2 times 1, that is 2. All right. So what are we having? D will now be equal to, all right, 2 plus 1. So we're having how many? We are having 3. 2 plus 1, that's 3. So we're having 3 degenerate orbital. 3 degenerate orbital. For which orbital? For the p orbital. So what does this tell us? It tells us that whenever we are talking about the p orbital, how many boxes do we draw? That's what this thing says. How many boxes do we draw? We have to draw 3 boxes. This is where all of those concepts you did in your introductory chemistry. You can see how we knew the number of boxes we have to draw for the p orbital. Do you understand? P orbital, we draw 3 boxes. We did not actually cram it. It's just understanding. It came from the concept of degenerate orbital. It is called degeneracy. I don't have to call big names, you understand? Just know that number of degenerate orbital means how many orbitals can we break in a particular orbital. How many boxes can we get from a particular orbital? You can see for the p is 3 boxes, and you can see the way we calculated for it. It is very simple. So what you do for me, you solve for question 39, 39 and 40, and as well as do the one I gave to you 37 and other practice questions I give to you in this video lesson. For more of my video lessons, make sure you click on this video you are seeing here on the screen. All right, so we've come to the end of this video lesson. If you find my video lesson helpful, make sure you click on the subscribe button and also share my lessons to your friends. Thanks for watching.